let's look at the components of an electrical submersible pump and then examine how it works. In this illustration, you see an ESP with the power cable, tubing, pump, pump intake, sealing section, and the electric motor that sits at the bottom. At the surface, the string is attached to a wellhead that is small and lightweight. The powerful, elongated, multi-centrifugal pumps are pushed to the bottom of the hole on tubing with the power cable strapped to the outside of the string. This heavily insulated and extremely armored cable powers the electric motor that is three-phase and operates at from 2,800 to 3,500 revolutions per minute, RPMs. It should be noted that extreme care is taken when pushing this cable to the bottom of the hole because it can easily be damaged. The pump intake includes a gas separator that diverts the produced gas up the annulus rather than through the pump as seen in this animation. The pump consists of a rotating impeller and a stationary diffuser that are stacked on top of one another in stages that operate in series. There are two other less used types of artificial lift. Power oil systems provide lift with pressurized power oil that is pumped down a separate tubing string. They are extremely useful when needing to control corrosive chemicals, dissolved salt deposits, and to reduce viscosity. Power oil systems are valuable in wells with deviated or crooked holes. Progressing cavity pumps are best suited for lifting heavy oils or solid-laden fluids. Now let's review. Together, artificial lift is principally provided by the sucker rod pumping system, gas lift, and electric submersible pumps, ESPs. The sucker rod pumping system, also known as the nodding donkey, is used mostly onshore because of its size and weight. Because of its relatively low cost, it is the preferred type of artificial lift wherever conditions warrant. Gas lift, on the other hand, is generally used offshore where the sucker rod pumping system is not suitable. It can also be used in wells that are deeper than those that can be serviced by the sucker rod pumping system. Because of its need for repeated maintenance and its dependence on a source of injectable gas, however, gas lift is the second choice for artificial lift. Finally, the electric submersible pump is reserved for wells either onshore or offshore with high production rates that can justify its relatively higher cost. Like gas lift, it can also be used in deep wells. Chapter 10 is about artificial lift, what it is and why, when and where it is needed. To begin, we discussed two different sources of energy, natural and artificial, that can be used in the initial and subsequent stages of recovery. The first source, natural lift, is most commonly used in recovery in the initial stages of a reservoir's production. The second source, artificial lift, is man-made and used in subsequent stages of recovery to supplement the reservoir's natural lift when it is no longer capable of lifting the oil in the hydrostatic column to the surface. Defining natural lift and then describing when and why this natural lift might end and be replaced with artificial lift, we outlined and highlighted 3 of the 5 different types of artificial lift: sucker rod pumping system, gas lift, and electric submersible pumping, ESP. We briefly mentioned power oil systems and progressing cavity pumps. All in all, this chapter illustrates ways that natural energy in the reservoir can be supplemented by various lifting techniques to capture as much of the hydrocarbons as possible in the reservoir.